The directions here are simply ask you to multiply. And like always, I always like to go back to early elementary, middle school, or high school principles that led the way up to us being able to do this. So let's say we have, I think I did 3 over 7, 21 over 42. 3 over 7 times 21 over 42. Same sort of setup. I'm multiplying two fractions. Now, you may have never seen this before, but one particular way that we can actually work this fraction here, multiply this fraction, which we will use a similar technique here, is I can break down each of these numbers into a product of prime numbers. 3 is already prime because it only takes 1 times 3 to get it. 7 is already prime because it only takes 1 times 7 to multiply together to get it. But if I break 21 down into a product, meaning something times something times something, or how many ever factors we need to get 21, we just need to make sure they're all prime. So in this case, 3 times 7 is definitely 21. Both of those are prime. Now, if I do 42, I can actually use 6 times 7, where 7 is prime, but the 6 would need to be broken down into prime numbers. So 42 would be 2 times 3 times 7. And then I can begin to cancel out. 3 goes into 3 once. 3 goes into 3 once. 7 goes into 7 once. 7 goes into 7 once. So there's no more cancellation. So now I can just multiply straight across. 1 times 3 times 1 is 3. 1 times 2 times 1 times 7 is 14. And that's how I can actually multiply those fractions. So we want to do something very similar with the problem right here above. So for the first numerator here, I want to factor out the GCF, which is 7. And then if I write what remains, I have x minus 2. Okay, so this is similar to breaking down like 21 and 42 into a product of its factors. Okay, if I do the same thing with 3x plus 6, 3 is the least common denominator. This will be x plus 2. Okay, same thing for the numerator. 4 is the GCF. Got x plus 2. And in the bottom, I have 6 times x minus 2. And so similarly, we can cancel out the x plus 2's, the x minus 2's, and we do. So one thing that I did not discuss up here is that you can cancel out diagonally, okay, that way, or vertically, but we cannot cancel out horizontally. Okay, so if I were to, for example, if I were looking at 3 and 6, these numbers are horizontal in relationship to each other. And even though I can cancel them out using 3, we are restricted from canceling out horizontally. You can either cancel diagonally or vertically, okay? So with that being said, I can, however, though, cancel out 4 and 6 using 2. 2 goes into 4, 2. 2 goes into 6, 3. And the cancellation is over, so that this final answer is 14 over 9.